Welcome to Rges Algebra 1. This is Lesson 21B, and we will be in Section 9.6. This will relate to understanding and writing scientific notation, going back between very large and very small numbers and their scientific notation, and then also being able to compute with scientific notation. Now, scientific notation is very, very useful because it's difficult to maneuver with very large and very small numbers. You probably know that if you've ever attempted to read very large numbers or count off the number of zeros. It's very difficult sometimes to be accurate. So it's much easier to write in scientific notation. In addition, there's a limit to the number of decimal places we can manipulate with a calculator. And that's another good reason to work with scientific notation. So let me give you an example here. We're going to write three very large numbers. And I'm trusting this is perhaps somewhat reviewed to you. So I'm going to be doing this kind of a brief explanation here, but here we go. Okay, we have three large numbers. The first one's very, very large, and we're going to put them all in the scientific notation form, which has a number without the trailing zeros, if it's a large number, times 10 to a power. Okay. So for very large numbers, this is going to be a positive power, and we're going to only look at the number part first. That would be all the numbers without the trailing zeros. This is for large numbers. Now, because it has a 0 between the 7 and the 4, that's irrelevant. That's going to be part of the number part. Here we would go until we have trailing zeros, and here until we have trailing zeros. Now we're going to write each of those numbers with a decimal point after the first value. So this will go to 9.3704 times 10 to some power. We'll come back for that. This will go to a decimal is always after the first value, 5009 times 10 to some power, and 8.403 times 10 to the power. Now, the next question then becomes, how many places, now in these large numbers, my decimal point, if I had written it, would be positioned right to the very right of the last zero. Okay. Or maybe I said 0.000. You probably wouldn't do that if you have no numbers to the right, okay? So assume it's going to be there. You probably never see a decimal there. And you want to count how many places did I move over from that point to where I placed the decimal, which is right there. Or from there to there. Or from there to there. Okay. So now we need to count those. 2, 4, 6, 8, 10, 12, 13. So this would be the number times 10 to the 13th. If I'm converting again from a very large number, once I've got the number port, I'm counting over how many places I moved that decimal. 3, 4, 5, 6, 7, and 3, 4, 5. So put it on pause, make sure you understand how you get those three exponents. Now to go in the other direction with a very large number, let's say I want to go with scientific notation, 7.904 times 10 to the 13th power. How would I write that out? Well, I would simply write 7, and then I'm going to count over 13 places, including these three. 1, 2, 3, now zeros, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Set some commas in there so I can make some sense out of it. And that would be 100,000, million, billion, trillion, 79 trillion, 40 billion. Okay. And you can see why I prefer scientific notation. Okay. So again, let's do another one. If we had 3.025 times 10 to the 7th, I would write 3.025. I took care of 3 of them, and now I need 4 more zeros. 1, 2, 3, 4 to get 7 places in all. That's a 0. Place my commas, and I've got, did I place them right? Yeah. So 100,000, million, 30,250,000. Okay. Now, to do very small numbers, we're going to do it the very same way, except now our exponents are going to be negative. So we'll have 0.000305, 0.0000010021, and we'll just do those two. Again, just look at the number part without the preceding zeros. We should not have any trailing zeros here. Write these numbers with a decimal point to the first place. So we would write 3.05 times 10 to a negative power, because we're going to go to make a small number here, a much smaller number, and we're going to write 1.0021 times 10 to the negative power. So these powers are going to be negative, indicating they're going to be very small numbers. So now, all I have to do is figure out that now where have I moved the decimal point? I've moved it from here to right after the 3. I've moved it over 4 places, so that would be to the negative 4. Here, I've moved it to after the 1. I've moved it over 6, 7 places, so that would be to the negative 7th. So that's how we write and go back and forth between very large numbers and scientific notation. Again, if we did it on the other side and we said 2.105 times 10 to the negative 3, I would write 2105. My decimal point was here, and I would go now to the left 3 places. So I'd move it over 1 to get it here, and then 2 more for my zeros. So my answer would be that, 0.002105. Now, the heart of the matter is going to be, how do I then do mathematics? Okay, so he gives you several examples, more examples, but then what do I do if I want to take 7.82 times 10 to the 4th, 3.4 times 10 to the negative 9th? Well, this is actually very easy. I'm going to multiply these two, and you can use the calculator to do that, and then I'm going to do multiply these two. And you know the rule for that, we add exponents. So I'm going to get, if I had it on the calculator, 7.82 times 3.4, I would end up with 26.588 times 10 to the, adding my exponents, negative 5th power. Now, I'm not in proper form yet because I always want my decimal point after just the first number. So let's change that to 2.6. Let me go ahead and round it. You don't have to, but I'm going to 66 times, that would be times 10 to the 1st, showing that I've moved this decimal point over one more time, because if I multiplied it by 10, I would get back to 26. Okay, and then don't forget the other 10 to the negative 5th. Add these again. You could do that in your head or on paper. 2.66 times 10, negative 5 plus 1 is negative 4. And they're all the same. Whether I were dividing, I'm just going to divide the number part, subtract the exponents. If I were, and then make sure you put it in proper form. Let's do something, one more kind of example here. What if I had I'm going to make something simpler than he had. What if I had 3 times 10 to the minus 5th all to the 3rd power? Well, let's do to the 4th power. Okay. Well, I'd take 3 to the 4th power, that'd be 9 times 9, or 81, times, multiplying now, 10 to the negative 20th, and then put it in proper form, 8.1 times 10 to the 1st, times 10 to the negative 20th. Add these, and you get 8.1 times 10 to the negative 19th. And that would be my final answer. So go ahead and study all of his practice problems. I don't think the idea is too hard, and I think you've had some exposure to scientific notation, but he's got good examples. And the key, of course, to the mathematical problems is you always deal with the number part separately and the exponent part separately. So go ahead and give those a whirl, and we'll take a look when you get back at any questions you might have.